The 1859 Carrington Event was the most powerful solar storm ever recorded, causing global auroras and widespread disruption to our primitive telegraph systems at the time. On the 1st of September 1859, British astronomer Richard Carrington observed a massive solar flare erupting from a sunspot roughly the size of Jupiter. This flare triggered a coronal mass ejection, which was a huge burst of solar plasma and magnetic particles that reached the Earth in just 17 hours, which is an unusually fast arrival time. There were two bright flashes on the sun, marking the start of the solar storm. This caused the coronal mass ejection, which slammed into Earth's atmosphere, sparking the most intense geomagnetic storm in recorded history. There were auroras worldwide, and normally we only see auroras such as the aurora borealis or the aurora australis near to the poles. However, this time auroras lit up the skies as far south as the Caribbean and Panama, with reports of red and green lights visible in places that had never seen them before. Back then we didn't have the internet, TVs or telephones even. Communication took place through the telegraph system using dots and dashes sent by Morse code. However, there was huge telegraph disruption. Telegraph systems across Europe and North America completely failed. Some operators received electric shocks, and telegraph paper even caught fire due to the electric currents that came through the systems. These days we are so much more reliant on electrical systems for communications, banking, security, transport, GPS, energy, defense capabilities, not to mention our space assets such as satellites and the International Space Station, etc. So if a Carrington scale event occurred now, it would bring the world to a complete halt in many ways. There would not just be some minor disruption, it would be chaos, and people will die. It may even result in martial law being declared. What will make a future solar storm event even worse is the fact that our magnetosphere is severely weakened, and this weakening is continuing to occur at an accelerated pace. If you've been watching some of my previous videos, you'll know that we are at the beginning of the next magnetic pole shift. The event is already underway. One of the effects of this event is a weakening of the magnetic field as the poles begin to move to their new location. They are approaching a tipping point, with the next geomagnetic jerks due between 2033 and 2035 and 2043 and 2045. The tipping point is where the acceleration of the pole shift, which has been speeding up over the last 60 years, finally gathers momentum and boom, shifts once and for all, leaving us with little to no magnetic protection at all. It may happen during the next geomagnetic jerk in the next 7 years, but if not, it's highly likely to happen by 2045. So the weakening of the magnetic field will keep happening in the lead up to this event, and the chances of a Carrington style event will get more and more likely. So if a Carrington scale event occurred now, what would happen? Well, it would knock out satellites, it would disrupt GPS and communications, it would cause widespread, significant power grid failures, and Apparently, it will lead to economic losses in the trillions of dollars. It's all serious stuff. And this is not fringe science or conspiracy. This is fully mainstream. Just look it up. Ask ChatGPT, Google it, whatever. The European Space Agency, the ESA, just ran its most extreme space weather simulation yet, planning for such future events. And guess what? This scenario was assessed and measured and was found to be so severe that no spacecraft would be left unscathed. The European Space Agency staged the exercise at its Mission Control Center in Darmstadt, Germany, to test how its satellites and operations team would respond to a solar superstorm such as the 1859 Carrington Event. The simulation was designed to test spacecraft operations and space weather preparedness ahead of the upcoming Sentinel-1D mission set to launch in November. Thomas Ormston, Deputy Spacecraft Operations Manager for Sentinel-1D, said that if an event does occur, there are no good solutions. But the goal would be to keep satellites safe enough and limit the damage as much as possible. However, in the simulation, the Sun unleashed a triple threat. This was just a simulation. First came as an enormous X-class solar flare. The radiation hit Earth within 8 minutes, disrupting communications, radar, tracking systems. Then a barrage of high-energy protons, electrons and alpha particles followed, striking spacecraft in orbit, triggering false readings, data corruption and potential hardware damage. Then about 15 hours later, a mass coronal ejection slammed into the Earth's magnetic field. The planet's upper atmosphere swelled, increasing drag on satellites by up to 400%, knocking them from predicted orbits, heightening the risk of collisions. Satellites are basically predicted to fall out of the sky and come crashing down to Earth. On the ground, the simulation found that the same storm would overload power grids and pipelines with geomagnetic energy. The simulation forced the European Space Agency's mission controllers to make real-time decisions, offering an insight into how to plan, approach, and react when such an event occurs. The exercise demonstrated how a severe solar storm could cascade across systems, from satellite failures to degraded navigation to the loss of critical communications. The scientists warned that such an event is actually inevitable. According to the coordinator of the simulation, the key takeaway is that it's not a question of if this will happen, but when. But what can we do? How will a solar storm Carrington scale event affect our household technology? Well, let's talk about the usual technology that we have in houses. So direct laptop damage is relatively unlikely. Laptops themselves are low voltage devices, so they're not directly vulnerable to geomagnetic currents. However, if your laptop is plugged in during such an event, they could be damaged by voltage spikes, especially if not protected by surge suppressors or uninterruptible power supplies. However, infrastructure collapse is the bigger threat. Geomagnetic storms induce currents in long conductors like power lines, potentially frying transformers and causing blackouts. There will be power grid failures, and forget having these power grids fixed quickly. Energy companies routinely respond to power failures caused by lightning strikes, storm damage, etc. And there is the capacity for power to be restored after a few hours, or at worst, several days from these events. However, a Carrington scale solar storm might result in whole countries being off the grid for weeks or even months. It's about resources. And if there are any closet preppers out there, I know I'm one, now is your time to shine. Imagine the chaos. Your fridge is out of action. So are all the supermarkets' fridges. Hospitals, no power. Train lines, no trains. It might be time to buy that backup power generator. And there will obviously be some significant internet disruption. Undersea cables and data centers could be affected, leading to widespread internet outages, but as I said before, there won't be any power anyway. It will be somewhat eerie. Imagine having no power at all, but also not being able to go online to get any updates, not knowing what's going on. There will be mass panic, and this is why I mentioned about martial law. It might be time to purchase that old school transistor radio to get emergency updates. But just all these things we take for granted. The satellite damage will knock out all GPS. Does anyone know how to use an old school paper map these days? Does anyone have a paper map? And timing systems will fail. Many networks rely on satellite-based timing. If those systems fail, it will disrupt banking, trading, cloud services that your laptop connects to. A Carrington-like solar storm wouldn't destroy electric cars, I don't think, directly, but it could disable the infrastructure that they rely on, like charging stations, GPS and cellular networks. But be careful. If an electric car is charging during a power surge, like the Carrington style event, it could suffer damage to its battery management system or onboard electrics, especially without surge protection. Some people might be thinking, I'll be okay when the grid goes down, I have solar panels. Think again. The solar panels themselves are resilient. Photovoltaic cells are passive devices and unlikely to be damaged by solar radiation or geomagnetic currents. However, the inverters are at significant risk. The maximum power point tracking inverters that convert solar DC to usable AC are sensitive electronics. A strong geomagnetic storm could induce voltage spikes that damage or destroy them. Also remember, most residential solar setups are grid connected, so if the grid goes down, these systems automatically disconnect to protect utility workers, leaving you without power unless you have a battery backup. The batteries themselves are robust. Lithium-ion batteries are not directly affected by geomagnetic storms, but battery management systems are vulnerable to electromagnetic interference or power surges, especially if charging during the event. So off-grid capability matters. If your system includes islanding capability, for example, it can operate independently off the grid, you may still have power during an outage, assuming your inverter and battery management system survive. So what should we do? The important things are: use surge protectors for all electronic devices. Back up important files offline in case cloud services go down. Stay informed with battery-powered radios or offline emergency apps. Monitor space weather alerts from your local space weather agency so that you can disconnect your system during high-risk periods. Avoid charging your electric car during solar storm alerts. Park your electric car, if possible, in a garage or underground structure to shield from electromagnetic interference. And keep your battery partially charged in case you lose access to charging for days. And download offline maps if you haven't got a paper one. Don't use elevators if there is a solar storm alert. unless you want to be trapped for weeks inside one. And do not use underground electric transport systems if there is a solar storm alert. It's probably a good idea to buy a backup generator and stockpile enough fuel to run it for several weeks. I would probably also stockpile food, drinking water and other critical supplies, probably enough for 6 to 8 weeks. There have been other solar storm events in recent years. There was one recently in Spain and Portugal, which for some reason has not been formally acknowledged. The 1989 Quebec blackout, caused by a less intense solar storm than the Carrington Event, knocked out power to 6 million people for 9 hours. This highlights how geomagnetic currents can overwhelm transformers and grid infrastructure. Here's what I find quite interesting. Studies suggest that Carrington scale events occur roughly every 500 years. I do not personally agree with this assessment. The data is somewhat speculative and does not take into account some significant planetary changes currently underway. Just remember that as our magnetosphere weakens, even the minor events, such as the case of Quebec, will also cause significant damage. And here's where we put it into perspective. The magnetosphere is already 30% weaker than it was in 1859, 30% weaker. Plus, we are so much more reliant on technology and electrical grids. A similar storm today, as I said before, would cause trillions of dollars in damages and take months to recover from. And on an even more sobering note, when the magnetic pole finally shifts sometime in the next 5 to 15 years, every day will be solar storm day, as our magnetosphere will only be pushing out up to 30% of its current protection. Do the research and get prepared, not just for the next solar storm, which is a case of when rather than if, but also prepare for the upcoming magnetic pole excursion.